Think about the Amazon boxes that come to your house where every little thing is wrapped in plastic. When I wash my clothes, little bits of my clothing come off in my washing machine. When I drive, little bits of tires go into our environment. So I think we let this happen slowly over time. We didn't think or see the large negative consequence that might ensue, and change is hard.
It exists in the furthest reaches of outer space. It's in every cell of your body right now. And it covers over 2/3 of our entire planet. What are we talking about? Water.
The water here is pristine, but more and more, what lies beneath our lakes and oceans includes plastics, lots of it. It's the largest type of marine garbage, but it's the tiny pieces of plastics or microplastics that are especially concerning.
Microplastics are small pieces of plastic that are less than 5 millimeters long, or about half the size of your fingernail. These pieces further degrade into microscopic pieces, and then they get everywhere. They start off as innocuous little bits in things like toothpaste and exfoliating facial scrubs. In our kitchens, they fall off of our pot scrubbers and wash down the drain. Or they come from the breakdown of the mountains of other plastics that we use. But even more alarming, they're found in our bodies and in the bodies of fish and wildlife. To help me get to the bottom of how this plastic pollution problem got so out of hand, we have Chelsea Rockman on the show. Dr. Chelsea Rockman is an assistant professor in the Department of Ecology and Evolutionary Biology at the University of Toronto. When she and her team use microplastics to investigate the ecological implications of our trash and its impact on freshwater and marine ecosystems. Chelsea, why are there tiny pieces of plastic in our water, and how did they get there?
Big picture, they're there because plastic has become such a common part of our life. I'm sitting on a couch with plastic textiles, the glasses on my face, the computer I'm talking to you with. You just look around your room, there's plastic everywhere. It's become such a common staple in our life. The way we manage that plastic isn't super sustainable. Most of it goes to landfill. Very little of it is actually recycled. It gets into the environment from poor waste management, from wastewater, from agricultural runoff, but it also includes weird things you might not think of that aren't necessarily garbage at the end of life. Like when I wash my clothes, little bits of my clothing come off in my washing machine. When I drive, little bits of tires go into our environment. So it's a complex issue. There's a lot of it out there, and it comes from a lot of different sources.
How have we allowed this to happen?
Go back to the beginning of plastic. It was right after World War II.
Today's military weapon becomes tomorrow's peacetime instrument. Plastics will play as large a role in peace as they do in war.
It was seen as one of the next best things. It was this miracle material that was going to make our lives more convenient. We took a material that we really had a lot of hopes for, and we've just found a million uses for it.
Plastic, plastic, plastic.
And some uses you could say aren't necessary. Think about the Amazon boxes that come to your house where every little thing, although they're trying to do less, is wrapped in plastic. Individual toilet paper rolls wrapped in plastic. We're also over packaging. So the amount of plastic we used to produce in 1950 when we started was about 500,000 tons per year. Today, it's nearly or just over 400 million tons per year. Almost half of that is used to make single-use plastic products, which are used once and then often thrown away. And these are the materials that are sometimes getting into the environment. So I think we let this happen slowly over time. We didn't think or see the large negative consequence that might ensue, and change is hard.
I hate to admit this, but knowing that most of the plastic doesn't make it into the recycling stream, it's sort of a disincentive for me to be like a real conscientious recycler. Do you think that's common?
So let's talk about recycling, and let's go take one step back and say, if recycling is part of the solution, that means we're trying to change to something that's become sounding a little bit like a buzzword, is a circular economy. To switch to a circular economy means we need to value plastic. It's made out of fossil fuels. It's an important value material that we shouldn't be throwing away and wasting. And to have it retain its value, we have to keep it in the system. So we have to close the loop. Means we make the plastic, we use the plastic, and instead of wasting it, we put it back into the system to be recycled into a new material. Right now, 9% of all plastic that we've produced since the beginning of time has been mechanically recycled into another object. That's crazy. 9%. We haven't set up the system for recycling to work. We have to make products that fit the recycling facilities and make products that allow them to be made out of recycled content. I also co-founded an organization called the U of T Trash Team. Our mission is to increase waste literacy. The reason for that is that I want you to go to bed at night knowing every material that you buy, which bin it goes in your house, and feel confident about where that bin goes. If we recycle wrong and put the wrong materials into the bin, then sometimes that whole bin goes into the landfill. And so having a contaminated recycle bin is part of the problem. But it's a systemic problem, right? Because that started because you didn't trust the system and you knew that a lot wasn't getting recycled. So we really have to fix this at several levels, which starts at what we're producing, then goes to building the waste management system, educating the public, and changing behavior.
Now let's go back and talk about microplastics. Most people think about plastics and they think about the ocean gyres and the big plastic patch in the oceans. But you've sort of said that the community is sort of turning around and looking upstream, literally, and looking on land. Is that more recent?
Research on plastic started in the middle of the ocean with the garbage patches, right? In about, 1996 in some ways, but early 2000s, it really started to become well known. At that point, we realized the majority of the plastic in the ocean, when we went out to these garbage patches, were not big pieces of things floating around, at least not by count. They were small bits of plastic the size of a pencil eraser or smaller, and a lot of them looked like just this colorful confetti. When you think about that, you think, well, how in the world am I going to clean this up? It's like trying to scoop the water out of my bathroom when my bathtub is overflowing rather than turning off the tap downstairs in the basement to make the water shut off. So we started doing work on land. And when we started doing work closer to land, we started seeing different types of microplastics, different shapes, different sizes, different chemistries, and really, really diverse, and realizing all of the sources they were coming from land. And of course, seeing larger concentrations near the coast. So I started my work off in the middle of the ocean, which is beautiful and sunny and bright blue waters. And now sometimes I work in a wastewater treatment plant, which is a little scummy and smelly and has a roof over it, but it's important. So
I've been in those wastewater facilities. Let me just throw this one at you. So, my background's in geology, and I sort of think of plastic, like a rock, like it just gets out there in the environment, and then it becomes part of the Earth system. It erodes, it breaks down, it's in the water, the particles get really small, they get transported, they end up in the ocean. Is that crazy?
No, it's not crazy. There are a lot of different fundamental cycles on our planet that we know are important, and we're starting to understand how plastic interacts with them. It's not just something that we've put in the environment anymore. When it comes to geology, it is, they think, going to be the marker of the Anthropocene, in that it's going to be this material that it's going to be there for a while. When it comes to the water cycle, we know it's being lifted out of the ocean and into the atmosphere, and then it's following in with global dust cycles, sometimes to far away locations. When it comes to the carbon cycle, we're starting to see evidence of dissolved organic carbon from plastics being implemented into the food chain. So we're starting to see that it's not just this material that's being put into the environment that we can take out. It's becoming part of these fundamental planetary cycles.
How long is this stuff going to be around for? Are we literally talking about forever and millions of years from now and seeing it in geologic layers?
Unfortunately, I don't think there's a clean answer to that question. Goes out into the environment. We know that via sunlight and mechanical processes like waves and sediment hitting it, as well as biological processes, that it will degrade and fragment into more pieces. How long it lasts, whether it's decades, hundreds of years, thousands of years, millions of years, no. And I think that's what a lot of people are trying to understand right now, is like, how are organisms evolving or maybe already able to use this as a carbon source? Does that mean it's going, quote unquote, away? When it buries in the sediment and isn't available maybe to some of those organisms, does it last longer? So these are all questions we're trying to understand, but I can tell you that in areas like the Tijuana River Valley, where plastics are entering this area and sediment is continuously washing in that area, you dig and there are layers of plastic. And it's hard to imagine that hundreds of years or thousands of years from now that would be gone.
I always thought of it in terms of like concrete and buildings and stuff like that. But, those things will probably degrade compared to the plastic. Hard to know. We should get in our time machine.
We should
go. And this could be an interesting sci-fi movie.
Roads? Where we're going, we don't need roads.
Anyway, let's talk about the implications for microplastics in the environment. Are they detrimental or are they just taking up space?
That is my favorite question.
I'm so glad I asked it.
When it comes to large plastic, just to zoom out really quick to plastic, there's no doubt that it entangles animals. We have whales washing up with bellies full of plastic bags. We know that it causes harm. With microplastic, the easiest way to study it and understand harm is laboratory experiments. We know that microplastics can cause harm at certain concentrations to animals, just like pesticides can cause harm at certain concentrations to animals. We know that the toxicity differs by microplastic type, just like it differs by different types of pesticides. But it's hard when you have something like a tiny particle that you're trying to tie to harm in the environment, because you have to correlate versus see the causation of harm. We don't see a fish washed up with a belly full of microplastic and say, oh, hey.
If I walked into your research lab at the U of T, what would I see? What does it look like?
You would walk into the lab and first you would see 1 million white cotton lab coats and jumpsuits and a HEPA filter and things that we use to try to keep microplastic contamination out of the labs. Further in, and you see instruments for quantifying microplastics. You see students with their heads in microscopes counting microplastics.
They're literally like counting little tiny particles by hand.
Sometimes they are. Yeah, yes.
I hope they were paid well.
They were all paid. It wasn't slave labor, but it was a lot of time under a microscope. So now we spend a lot of time trying to figure out how do you automate this process, because it's very time consuming.
I've seen some stuff on sort of AI. You'd have to sort of train the software to recognize a plastic particle from whatever. In your lab or in your research team, do you have a preferred size of particle that you like? Are there specialists in like different size ranges?
Phrasing?
Sort of. Yeah, there are sort of specialists in different size ranges. I would say that we specialize in particles that are 45 micron to 5 millimeter because we struggle to measure anything smaller. So we are trying to be able to get down to the 1 to 10 micron range. We would like to be able to quantify nanoplastics. Right now, I'd say most labs specialize in the same size range we do because the technology and the methodologies in order to get smaller are either not there or incredibly specialized. So yes, but it's not for any good reason that we specialize in a certain size range.
So how about in the field? What sort of sampling do you do?
So when we go out into the fields, if we're quantifying microplastic, we're either trawling in the water, like doing surface plankton tows. We're basically towing a mesh net. Sometimes if we're interested in the really small stuff, we're pumping water through sieves or just taking a grab sample of water to sieve back at the lab. We take sediments from the bottom, just like we would if we were looking for PCBs or pesticides. We take a grab sample of pesticides, put it in a jar, bring it home. If other people are sampling organisms for different questions, sometimes we'll take the gut content to try to understand what's in the organism, what it's eaten in terms of microplastics. And sometimes we sample air to try to look at how much microplastic is in the atmosphere.
What's your level of optimism about the future? Can we make the world a cleaner, less plasticky place?
So my optimism and hope are probably higher than one would think, because the answer of can we, it's not rocket science, right? We just need to use less of the material. There's lots of plastic items we interact with where you could imagine not interacting with them on a day-to-day basis. Do I think we need to ban all plastics always forever? No, I really don't. I just think we need to use the material maybe less. We need to use it in a more sustainable way. And what we have to do is possible, right? Like shifting to a circular economy. A lot of these technologies exist. Switching to materials that are recyclable. It exists, right? You just don't make a multi-plastic lining. You make a bag that's recyclable made out of one thing. So it's just getting things to change. Changing the economy, changing people's behavior, changing the government. That's the hard part. So the question isn't can we? We absolutely can. The question is will we and how soon?
It's that will to change, which is so common in all of these environmental problems. Well, thanks so much, Chelsea. It's been a pleasure chatting with you today and having you on the show.
Oh, thank you. It was fun. Fun to be here.
different size ranges.